All right, so for 5152, come on, drag down.
You're gonna have
Here's
to
our
roll
homework.
this with us. Here's your homework.
So when we talk about multiplying values, let's not dive right into multiplying fractions. We talk about multiplying any numbers. Why do we multiply? Like, what is the... We wouldn't actually have to have multiplication as a operation. Justin, why do we multiply?
To just not do as much work. Like in addition, we'd be adding tons and tons and tons. But with multiplication, we can just use two numbers and it's over practically.
Yeah, so multiplication is a shortcut. It is one of those make your life easier sort of things. So multiplication is used to replace multiple additions. That's the reason it's called multiplication. It is multiple additions. So instead of multiplying something, or instead of adding something over and over and over and over and over and over and over again, because that would get really, really lame, we just multiply. And like Justin said, you can just have one number to represent how many times you do it, and the other number to represent what number you're adding. Now, fractions get a little bit more different, a little bit more challenging, and they're not as easy to think about. So when we multiply fractions, think of this image right here. We have 2/7, and we broke my space into horizontal bars. We then are going to take 3/5 and multiply it. What word do we use to represent multiplication? What, like, if you want to say, like, I have, like, so many sets, and you're describing it, how would you say that? Yeah.
You have something times that.
Yeah, but there's another word that is not really a mathy word. It's just like a word that we use every day. Like if I say I have 3 dozen, like what would I probably say after that? Abby?
Each? Wait, no, each.
Justin? Groups. Okay, groups, that could work too.
Maybe rows.
Okay, maybe rows. The big word that I'm really trying to get us to get to is of. Of. The word of tells you to multiply. I'm not joking. So if you have 3 sets of 2, you're doing 3 times 2. If I have 4 dozen of something, that's multiplied. But 4 dozen has already done the multiplication. If I have 9 sets of 3, I really have 27. Of tells me to multiply these values together. So I have 2/7 of 3/5, or 3/5 of 2/7. So I had my 2/7, but then I need to break this whole set up into fifths and only look at 3 of them. So really, the answer to your multiplication, or the product, is the amount of overlap. If you have fractions times fractions, you can just set it up like this method and look at how much overlap is there. That's your numerator. How many total boxes are there now? That's your denominator. So we end up with 6/35 there because that is how much overlap exists. Do we have, yeah.
But isn't that just multiplying 2 times 3 and 7 times 5?
Sure, yes. But if we want a visual way to like think about why this is happening, so imagine these are pizzas. And you first cut the pizza into 7 rows. Then you cut your pizza into 3 columns, and our class is going to get 3/5 of the 2/7. We only end up with 6 pieces. There are 35 total pieces now, but if we get 3/5 of the 2/7, we would only get that overlap. So it's just a visual representation. But you're right. We just go straight through the top and straight through the bottom.
And
So
go with any number?
yeah, with any set of fractions.
Okay.
So here's our learning target, that we can accurately multiply rational numbers. Rational being any number that can be written as a ratio, so decimals count in that. And when presented with mixed numbers, I know to convert to a decimal or improper fraction, whichever is easier for you, before multiplying. Now, I will tell you, most people are like, oh, use decimals because we can use a calculator. Knock that off. Fractions are easier, and we don't need a calculator. So please quit resorting to let me reach for the calculator first thing. Use your brain first thing. If you can't figure it out by using your brain, then you might resort to a calculator. So if we look at -2 times 3, what property tells me that I can change the order of multiplication? The order, so 2 times 3 is the same as 3 times 2. And yeah, we can throw negatives in there. 5 times 2 is the same as 2 times 5. Order doesn't matter in multiplication. What property is it that lets me move things?
Ooh.
Shane? Yeah, did you find it on your paper? Yeah, it's on your paper, guys. So highlight or underline or something. The commutative property lets me move the order. So I would notate that commutative means to move or change order. Means to move or change order. So there's a great difference between a positive 3 and a positive 2 multiplying by each other, and a positive 3 and a negative 2. Now, can I actually do something a negative amount of times? Can I wash my car -4 times?
No.
No. I could go drive it through some puddles or something, but that does not mean I'm washing it negatively. Can I run -2 laps?
No.
No. But could I run 2 laps running backwards? Yes. So we apply the commutative property to make sense of these multiplication problems. So if you are presented with 3 times -2, that doesn't mean do 3 -2 times. I can flip that order around and say -2 times 3. I'm going to do -2 3 times. So I do -2, -2, and -2. I end up at -6. So that's why we apply the commutative property, is to make sense of the multiplication problem. Now, normally this leads us to the next question of what happens if I have 2 negatives, and we will get there. Easy answer is they cancel out and become positive. So, research scientists, one of the coolest jobs I think ever. Research scientists essentially collect data and try to apply that data to figure things out and solve problems. So, if you are a research scientist researching glaciers, you get to go hang out with glaciers for a long time because you need to collect data. So you have to be really, really interested in whatever you're doing, but I think it's a sweet job. Yeah.
Okay, so it's up at the top, it's 3 times -2
Mm-hmm.
equals 2 times 3.
-2 times 3. So you can't drop the negative.
-2 times 3.
Yeah.
And one more thing about the glacier. I climbed a glacier. It was awesome.
Yeah? Was that in Norway?
Yeah.
How big was it?
Really awesome.
Yeah.
Really big.
Really big. Was there any part that you could slide down, or was it all pretty jagged?
It was all pretty.
Yeah. So glaciers are sweet, but what does it mean if a glacier is retreating?
It's flying.
Yeah, help me with your name. I'm at a loss today. Anthony. Were you skateboarding home yesterday?
Yeah.
Were you texting while skateboarding?
Oh snap.
Just be careful. I don't know if it was you or Nick. Somebody on a skateboard was texting while skateboarding, and you were on the path.
I wasn't skateboarding yesterday.
Okay, so it must have been Nick. I'll go talk to Nick. But I talked to somebody about, please, if you skateboard or rollerblade or bike, please don't have headphones in. That's really dangerous. And I would caution you not to use your cell phone at all while doing that, because traffic doesn't pay attention. It's not you guys I'm worried about, it's everybody else. So Anthony, what's it mean to retreat?
Retreat, just go back.
Yeah, go back or run away or lose space, right? So if it's retreating 7 feet per year, that means it is probably melting 7 feet per year. Why might that be happening? This is something you'll discuss a lot this year. You know, Anthony?
Global warming.
Ooh, yes, but we don't really call it global warming. If you want to really impress Mr. Cabilo, what do we actually call global warming? The correct name for it is global...
Sun heating.
No. Global climate change. Because it's not just warming. That's not the only thing happening. It's that there's climate change happening in weird ways in weird parts. So it's not just called global warming. We call it global climate change. So if it's retreating 7 every year, that's like a -7. And if this happens for 4 years, then we're just going to lose 7 4 times. So it wants us to use a number line model So, am I ever going to go positive here? Do I know how big the glacier is to start? No. So let's just start at a 0. This would be where my glacier is right now. Big old jagged glacier.
Should we draw this number line?
Yep. You don't have to draw the glacier if you don't want to. But. So then when it retreats that first year, how much does it lose that first year? Every year it's losing 7. So we would now be at a loss of 7. And my glacier would be 7 feet smaller. My next year does the same thing, loses 7 more, but now I would be at negative 14, and now my glacier's here. Then I, again, the third year, lose 7, and now I'd be at negative 21. Careful, you're on the 4th year already. And then my glacier would be there. And my final year, I lose 7 more. And I would end up at negative 28, as somebody already said. And my glacier is much smaller. It is very sad. Yeah?
Why is that negative?
So, that's a great question. So Justin, let's say you don't have enough money for lunch. Or, no, let's flip this around because I have $1.25 left in my account. So I go to lunch and I'm like, man, I really, really, really want some Big Daddy pizza. Justin, can I borrow $2? Well, let's imagine that you're nice and you have lots of money. I don't know which one of those is a further stretch. So Justin decides he's going to be nice to me. He's going to loan me $2. I come on to the next and I'm like, ooh, Bosco sticks. But I use that whole $2, so I go to Justin again. I'm like, man, sorry to do this. Can I borrow $2 again? He's like, dude, you're the adult here. But he's nice and he gives me $2 again. Then the next day I'm like, ooh, chicken salad. But again, I forgot to bring money. And they don't want to accept my credit card. So I'm like, Justin, can I borrow $2 again? He's like, dude, I'm going to have to start charging you interest. We'll talk about interest later in the year. But I borrowed $2 again. How many times did I borrow $2 from Justin? 3 times, right? Big Daddy pizza, Bosco sticks, and a chicken salad. Now, what is our relationship right now? Debt, right? I am in debt to you. How much?
$6.
So currently my balance is negative 6. Because I owe you $6. That's the same thing happening here with the glacier. It loses 7 4 times. Just like you gave me, or like I borrowed $2 3 times from you, this glacier lost 7 4 times. So in total, it lost 28 feet or retreated 28 feet. So the change that happened to the glacier is negative 28 feet from wherever it started. So if we knew its start point, it lost 28 feet. This negative is just representing direction. So what that's telling me is that we had a loss or a melt, as opposed to if it was positive, that would tell me it got bigger, as opposed to it got smaller. So does that kind of make more sense why it's a negative? It depends what we're looking at. This, we were looking at where the glacier is. So looking at the mass kind of goes to a different area. So here, let's say, I'm trying to think of something that costs $8. Let's say you want to go to the movies. And this weekend's Labor Day, right? So on Friday, you're like, ooh, Suicide Squad. Mom, Dad, can I go? And they're like, I don't know. It's kind of a PG-13. I don't know if you should see it. So they say, okay, we'll go with you. And you get there, and your parents are like, well, you wanted to go. You've got money, right? And you're like, no. So you borrow $8 from your parents. And they're like, you're going to have to pay us back. Do some chores, something. Saturday, you decide to go to Finding Nemo or Finding Dory. Your parents are like, okay, that's a good movie. We don't need to go with you. You need money, right? So you borrow another $8. Sunday, there's no school Monday. You go to another movie. You borrow another $8. How much money have you borrowed? Surface? 24. But have you gained that money? No, really, you've lost that money because now you are in debt. So if I borrow $8 3 times, I end up in debt $24. The biggest thing here is that if your problem involves a single negative, your answer will be negative. If your problem involves multiple negatives, then you got to turn on the brain and figure things out. So we will look at that situation.
So that means it's negative.
Just a second. Or the opposite of negative. And Abby, what's the opposite of negative?
Positive.
Positive. So, write negative 20 in 3 or more if you want, different ways using one positive and one negative integer. Integer, so don't get crazy. No fractions, no decimals. Integer values. One positive, one negative. 3 different ways, at least.
Done.
Who's talking about canteens? It's not DJ Hudson, it's DJ Hudcat. You never choose your DJ name. Your DJ name must be given to you. That's a rule of
What's
I don't know,
Hudcat?
it's just a DJ rule. You don't choose your name, it's given to you.
What's Hudcat?
So my name's Hudson, right? And I like to work on cars. I used to a lot more when I had to. When I had like my old Honda or my old Jeep that I had, it was always breaking down, so I was always working on cars. So that was where my DJ name came from. Jaheim, help me out. What's one way you wrote this product? So you got to use one negative and one positive, right? So I'm going to go ahead and put parentheses here for the negative, and it's going to multiply by something. And I'm going to put a little divider here. Or did you have a question? I saw your hand. I thought you were trying to give me an answer. So pick one factor of 20. So numbers that can multiply into it. And let's just make it negative. So do you want to choose 2 or 4 or 5 or 10 or 20 or 1 or there's all those different factors. 4. So let's say negative 4. So what would 4 need to multiply with to make 20? Since I've used the negative, I know this one will just be positive. 5, right? So negative 4 times 5, that's one of our possible products that we can use here.
Or negative
Question?
4 times 4 commutative property.
Are you trying to give me another?
Yep.
I'm going to bounce around. Who else?
What are you looking at?
Yeah, Xavier.
Negative 10 times
Negative 10 times, what was it?
2.
2. Shane?
Negative 20 times 1.
Yeah, I can use the number itself and just multiply by 1. If I do something one time, I end up with the exact same thing I started with. And with all of these, could I have used 4 and negative 5?
Yeah.
Could I have used 10 and negative 2?
Yeah.
Could I have used 20 and negative 1? Now, wait a minute. You're right. But so what we're really saying, and I love that you give me that example, what we're really saying is 20 is actually a negative 1 times 20. To make a number negative, there's really actually a multiplication happening. So on your homework tonight, you need to be really careful, and you're lucky that one of the students in the accelerated class notified me about this. They called me last night. He and his dad were arguing about this. There's a problem that is this. And what I will caution you, and we're going to talk about powers. We're going to get there in just a second. What I will caution you about is this is not negative 10. This is the opposite of 10 squared. And why that is according to order of operations, which comes first? Exponents or addition subtraction?
Ooh.
Anybody?
Exponents.
Exponents, right? It's parentheses, then exponents, then multiply, divide, then add, subtract. So my exponent operation has to happen first, and because this is not in parentheses, it's not joined up. Now, if this was, and what the dad thought it was if this was negative 10 squared, that's how the dad was looking at it. But we would need the parentheses to group my negative. Otherwise, this is just the opposite of 10 squared. because I have to do the square first, then the arithmetic symbol happens. So be careful with that problem. If you struggle with it, come see me.
I tried to do it.
Yeah. Yeah, you're good, man.
Isn't it like negative 10,000 What?
All right, so
No, I don't make sense.
here, the distributive property, and we're going to talk a lot more about this as we get into this chapter, but the distributive property takes a multiplication and breaks it up to the things it's multiplying to. So, -1 plus 1, what would this be inside the parentheses? Negative. Yeah, they're additive inverses, right? It tells us right here. So if I apply the distributive property to look at this, and I say -1 times 0, well, really, that would be -1 times the -1, and -1 times the +1. Now, a -1 times a -1, a negative times a negative. So think about Justin and my relationship with the debt. I owed him $6. Now, if I go negative time from now, if I go back in time, can I get rid of that debt if I go back in time?
Yes.
If I go back in time 3 days and I never borrow money from Justin, I can get rid of that debt. So that -6, if I go back and I divide by the -3 days, I would see that every day I was borrowing $2, but if I go back in time, I get rid of it. So anytime you have pairs of negatives in a multiplication or division, pairs become positive. So you could write that to remind yourself. Pairs equal positive. So pairs of negatives. So these really become a +1, and this becomes a -1, and a +1 plus a -1 just equals 0. Pairs of negatives become positive. That's multiplication division rule specific. Wait, it's just capturing. Give it a second.
Yeah, because I know our smart boards would be like that. Like we would write something and it would like never show up on the
Right, yeah. This is actually the oldest smartboard in the school, so it's still doing pretty good. So we said that we said that -20 up here, what we could rewrite it as -1 times 20, right? Because it's just making a positive number negative. Let's do the same thing down here, and we're going to make -11 actually be -1 times 11. And then I'm going to make -7, because so back up. And I think we know this, but it's worth clarifying. What is going on when I have a number right up against a parentheses? There's no operation symbol in there. Yeah, do you know? It's multiplication. How do we know that? Like, why? It goes back to that whole, like, of. If I wrote something like this, this is telling me I have 3 sets. Well, how many are in a set? A set is 2. So if I have 3 sets, I have 6. But I have to know what a set is. So this would be like taking the sentence 3 sets and then replacing sets with a number. That's why there's really a multiplication dot in here. But as I'll say a lot of times, is your mathematicians are efficient. We like to do as little work as possible, which you guys don't believe right now. I know it. You're like, oh, math is just a whole bunch of work. Mathematicians want to do as little work as possible, but there's a certain amount of work that you have to do. So if I change my -11 into -1 times 11, what can I change my -7 into? Abby? Right here. -11, -7. Well, I'm going to use 7, I agree. But 7 times, Shane, the -1. Am I allowed to rearrange multiplication?
Yes.
What property tells me? Anybody? Commutative, commute means to move. So now I'm going to rewrite this. I'm going to have -1 times the other -1.
Ooh.
And then I'm going to have the 11. And then the 7. What happens when I have the opposite of a negative, or the negative of a negative?
Ooh.
Yeah.
I know that.
Well, be careful. The opposite of a you're thinking about additive inverses. So that would be like 3 and -3 when I add them. But now I'm multiplying two negatives. Surface? So the opposite of a negative.
Ooh. I know.
Yeah.
this. Make it positive.
It's positive, guys.
Make it all happen
So
again.
this goes back to the rule that if there's pairs of negatives, they become positive. Like when we had the minus the negative, like 3 minus -2, it's kind of the same that if we have -3 times -2, there's the opposite of 3 and the opposite of 2. Well, the opposite of an opposite just becomes the positive. So these make a +1. So really, does multiplication by 1, a +1, does that do anything?
No.
No. If I say I have 1 banana, okay, I have 1 banana. 1 does nothing. So, Lily, what do I do now?
Underestimate.
Oh, sorry, question.
Why are I don't get the got it.
This?
Yeah.
So, we've taken the -11, like we took the -20 up the page, and broken it into the -1 times 11, because that would make -11. Are you with me on that? How this would make -11.
Yeah, but what I don't get is why wouldn't you just put -11?
So, you can. I'm showing more work than needs to be shown to try to get us to understand this concept. I don't want you guys to just do stuff because I told you to do it. I want you to understand why we're doing it. Because that base of mathematical knowledge will serve you huge profit or dividends. It will help you a lot when you get into higher math to not just know a rule, but know why. So I can just tell you the rule, a negative times a negative makes a positive number, and then we can move on and you just know that rule. But the reason why it happens is if I break it up and look at the fact that -11 is really a -1 times 11. Or I could just have a negative times 11. I don't even need the 1. I can just have the opposite symbol. And same thing with 7. It's the opposite of 1 times 7, or just the opposite of 7. Two opposites make a positive, and now +1 doesn't do anything, so I can just forget about it, and 11 times 7 just gives me 77. So that's the reasoning behind how we get that. Do you need to show this work on your homework or anything? No, not at all. But we wanted to look at it so you understand why. So your rule with multiplication with different signs is right here. If you have a positive times a negative, it's negative. You only have one negative involved. Or if you have a negative times a positive, it's negative. You only have one negative involved. Now, different from this, if you want to put this out to the side, the same signs, such as -3 times -2, this will equal a +6 because the opposite of, because remember multiplication is of, the opposite of a negative is positive. Yeah, Colin. Yeah, you're good, man. We only have 6-7 minutes left, so try to hurry. Any questions? It's weird to get your head around, but if you are struggling on the practice, please come see me. We're going to skip this example because I don't have that thing loaded up, and we're trying to get through all this. So, suppose, I hate when they say suppose because I would rather actually define. So let's define P and Q. It says they have different signs with each other. So let's choose a P and choose a Q. What should P be? Make it something easy. Single digit number.
Ooh.
What do you think?
7.
7. Love it. Nice and prime. Q has to have a different sign. So, if we made P positive, Q's got to be negative. So we're going to make it negative. Yeah. 2. Sure. Perfect. Now, this problem is saying P times the opposite of Q. So I'm going to rewrite this. P times the opposite of Q would be, well, I plug in my P is just 7 times the opposite, and then I plug in my Q. Well, my Q is negative 2. So the opposite of a negative, I'm going to color code so this might make a little bit more sense. So that opposite symbol was different from this negative symbol. Q itself, the value of Q, is negative. But now we're looking at the opposite of Q. So what is the opposite of the negative? The opposite of the negative, Justin?
Positive.
Yeah, is the positive. So this really becomes 7 times 2, or 14. That is where we show that a negative times a negative, because really this is multiplication. Anytime you have things right up against each other, you're multiplying. So you could put a multiplication symbol here if you want, but you don't need it because the parentheses tell me to multiply. Justin?
So that little far away symbol means that it's the opposite.
That little far, which? This?
No. Out of the second set of parentheses, we consider
This?
over one.
That.
Yeah.
So this is the same thing as that one. That's why I highlighted them in green. So this statement right here is saying the opposite of the value of Q. And we know the value of Q is negative. So when we look at the opposite of the value of Q, well, the opposite of the negative number is a positive. Does that make sense?
Yeah.
This is weird because we have an opposite and then a negative, and they're two different symbols, which is why I tried to show them with the highlighter here. Other questions? Seriously, please ask them before we move on. It's just capturing. Justin?
Wouldn't you ever use that symbol in real?
So practical thinking of that is like if I owe my, let's say I'll use a real example. I owe, let's round it out, $150,000 for my house. That's a debt. So right now, my balance on my house is a negative $150,000. Every month, I pay my mortgage. And there's taxes and everything else tied up in there. But towards the house, let's just say I pay $1,000 towards the house every month. So I am putting positive money into there, right? And that's bringing the debt down. So if I want to look at where I have a balance of 0, I could go to that balance of 0 and then kind of work backwards in time, and I could figure out how many months or years, if you want to look at it like that, would it take to pay off that whole debt? So I have debt of the negative number and a negative amount of months because I'm kind of going back in time, and that makes the positive amount of money that I will have to put in. So it's weird to think about. It really is. Like a situation involving multiple negatives is very complicated. There are adults that can't figure out the negative work. That doesn't give you permission to not figure it out. You got to be the next generation that is smarter and better and fixes the world. So, opposite of a negative, because remember, I can call this many different names. I can call it a negative or an opposite or a minus, but it's not, there's no number for it to subtract away from. There's a parentheses. I forget what else I could call. I mean, there's any name that can be a synonym for negative or opposite could be used there. So, here, how many negatives do I have in negative 8.1 times 3? Joe, how many negatives do you see up here? 1, right? This is negative. So I have negative times a positive. So is that going to equal a negative or a positive amount? Negative, because I only have 1 negative. And that would really be negative 24.3. because I can do 3 times the 1/10 and 3 times the 8, and that is how I got that. I distribute my multiplication. So now powers. Really quickly before we get out of here, and just so you guys know, the Chapter 5 homework is secondary priority to getting all of your Chapter 4 taken care of. I will not be putting Chapter 5 homework into the grade book until we get past the Chapter 4 mastery. So get your Chapter 4 work done. Tonight, you don't even, I mean, you could start our Chapter 5.1, 5.2. I'm going to explain powers really quick, but I'm just telling you, there are some powers in your homework. If you get confused, skip them. So real quickly, a power is just used like multiplication is used. Multiplication is repeated addition, right? Powers are repeated multiplication. So all you really need, if you want to be able to help you on your homework, a squared really tells you multiply a twice. B doesn't have a power. Really, technically, it has a power of 1. We just don't show it. So that means there's only one B. So that would be a times B, because it's a squared. A to the third would be a times a times a. A to the fourth, a times a times a times a. And it keeps going and going and going. Any last questions? All right, have a wonderful day. Give your homework a shot. I will see you guys later.
Which one is homework?
The 5.1, 5.2 is 18 total, so there's like 9 from each section. So if it was broken up, they'd be pretty short assignments, but I sometimes just like to put them together so you just have one assignment to work in. And it's a little bit easier then, because if I only give you 9 problems, you'd have to get like 8 of them, or you can only miss 1 of them, right? So giving you more problems gives you a little bit more flexibility.
Yeah.